Hello grade 12s. This is an extension video on first principles differentiation. In the first video on first principles differentiation, I discussed the whole concept of first principles differentiation. I showed you where the formula came from, and I showed using the Nuzandi method step by step how you calculate the first derivative of fx using first principles. And then at the end of that particular video, I said we've run out of time. So this is then the extension, which is that, like I said, the Josh method of how can they complicate this? How can they make this look different? Something that's supposed to be stock standard and forward, how can they ask it in such a way that now suddenly it's confusing? So this is from the November 2018 IB paper, and it's question 4a. So they gave you the function fx is equal to 2x cubed. So that's your function. And now, instead of asking using first principles to determine the first derivative right there, they say determine the average gradient of f between the points x equal to 1 and x equal to 1 plus h. Now, this is actually supposed to be a very simple question, because in the very first video that I did, which is the introduction to differential calculus, we said the average gradient is then the f of x2 minus the f of x1. So please remember, this refers to the y coordinates. And then underneath the line, x2 minus x1. Now, remember I told you in the first video, there's a reason we use that f of x2 minus the f of x1 instead of using y2 minus y1. And I think it should become quite clear, it's because of all the substitutions we have to do into the function. So that's why, especially in differential calculus, we don't use y2 minus y1, but that's effectively what it is. It's y2 minus y1. So average gradient, that's the formula we're going to use, and we're going to go and we're going to substitute this in as x2, and we're going to substitute this in as x1. So I'm going to go and I'm going to say the f of x2 is then substituting 1 plus h into that, so 2 times 1 plus h to the power of 3, minus the f of x1, which is then going to be 2 times 1 cubed. And then in the denominator, I'm going to go x2 is then 1 plus h minus x1, which is just 1. Now, you'll see the denominator is actually very easy to simplify. But right there, that one, that's what makes this quite tricky to do. I now have to work out 1 plus h to the power 3, which I don't think you guys have done since you were doing products in grade 10. If you don't want to go and expand it in the formula, you could quickly go and just on the side calculate what is 1 plus h cubed. So I'm going to do that just so that you guys don't get too lost. So I'm going to say, if I want to calculate 1 plus h cubed, I can rewrite it saying it's 1 plus h times 1 plus h squared. And the reason I do that is simply because I've got a lovely little shortcut for calculating a binomial squared. So I'm going to say it's 1 plus h times 1 plus 2h plus h squared. Now, unfortunately, there's not really a shortcut for the next one. Well, at least not one that we teach you in core mathematics. So I'm going to have to multiply 1 by the 2h, and by the h squared. And I'm also going to have to multiply that h by all of those terms. So we start 1 plus 2h plus h squared. So that was obviously multiplying. And then we go to the second term, which is going to be h times 1, so h, plus 2h squared, plus h cubed. Right, and let me just keep this slightly separate, because I'm just trying to go and figure this out so I can substitute it in there into my formula. So simplifying it, I've got 1, and then I've got like terms over there. 2h plus h is 3h. And then I've got more like terms over there. H squared plus 2h squared is then 3h squared. And then I can just bring down that h cubed. So that's what I'm going to substitute into this part right there. So it's 2 times 1 plus 3h squared plus h cubed. Minus, and this is pretty easy, it's 2 times 1 cubed, which is just minus 2. Over 1 minus 1, which eliminates, so I've just got h at the bottom. And then finally, I can distribute that 2, so I've got 2 plus 6h squared plus 2h cubed minus 2 of h. And I think you're beginning to notice that this looks a lot like a first principles problem. And the reason it looks a lot like a first principles problem is, look at this. The term that does not have h as a common factor is going to eliminate, which means all the terms that are left has got h as a common factor. So in the next step, I can actually take out h as a common factor and say it's 6 plus 6h plus 2h squared. And I can divide away that h there, and I'm left with 6 plus 6h plus 2h squared. Now please notice, we are not going to do the limit of h tending towards 0 here, because they didn't ask us for the instantaneous gradient. They asked us for the average gradient. And this is what you need to recognize here. The way this question is set up is they wanted you to first do the average gradient, and then in the follow-up question, which is hence or otherwise, determine the first derivative where x is equal to 1. Now, that first derivative where x is equal to 1, if I refer back to this part, says we worked out the average gradient between 1 and 1 plus h. So h is a certain distance away from 1. And that's why I ended up with this particular result. But if I think about this quite cleverly, then I can go and I can make h tend towards 0. And if h tends towards 0, then it's no longer the average gradient between 2 points. Because if h is 0, it's actually not 2 points, it's 1 point. And because it's 1 point, I can then go and I can work out the instantaneous gradient where x is equal to 1. So all you had to realize here is you had to realize that you've done all the hard work. So the first derivative where x is equal to 1 is then going to be the limit of h tending towards 0. And we're going to put that in there, 6 plus 6h plus 2h squared, which is the average gradient. So always remember, the limit of h tending towards 0 of the average gradient is going to be the instantaneous gradient. And that is then just a simple substitution. I don't even have to go and manipulate this because I've already manipulated up top. So I didn't have to go and factorize or anything. I can just substitute in. And if I substitute in, you'll see I have 6 plus 6 times 0 plus 2 0 squared. Sorry, that should be a plus 2 0 squared. And that means I end up with 6. So what I'm saying here is I'm saying the first derivative, and remember I say derivatives, you say gradients. So that means the gradient of this function, of this curve, where x is equal to 1 is equal to 6. Now we are later on when we're going to do graphs, we're going to go and look at what these actually look like. Because it's quite interesting to go and realize that when you draw the curve, you need to understand the gradient actually refers to the steepness of the curve. But we'll get that later on when we get to drawing graphs using differential calculus. So yes, this was using the Joshua method, saying, okay, I understand first principles, but how can they make it difficult? How can they make it complicated? How can they make it different? So last year in the paper, they made it well, not last year, 2018, they made it quite different. So hopefully you understood what I did here. Thank you for listening.